welcome to a new edition of the Heat Treat podcast. Today we have a power player from the industry, president of Power Products, Ben Rassieur. How's it going, Ben?
It's going great, Carlos. It's good to see you again. Really happy to be here. I have an opportunity to kind of share our thoughts about where things are going in the heat treat industry, and looking forward to spending a little more time with you.
Good. Well, I'm really thankful that you took this time to record this podcast. It's such a great thing to have a guy with your experience talking to us about heat treat. I believe you know a little bit of this industry. You've been around quite a while. I took a look at your CV, but for the people that are not very familiar with Power Products and yourself, can you just give us an introduction to who you are, the company you represent, you lead, and the amount of heat treat that you do, because it's quite impressive.
Well, I'm the president of Paulo Products Company, and Paulo has been in the commercial heat treating business since 1943. It was started by my grandparents. It was actually my grandmother's idea, which is a long and complicated story I won't get into, but she decided that we should try being in the heat treating business. And it worked out. So I'm the third generation to lead the company, along with my brother, Terry. And our fourth generation is beginning to is taking over the leadership of the company as we speak. And those are my sons and one of Terry's daughters. We're really proud of everything we've accomplished over the years. We've gone from being literally in a small rented warehouse in 1943 to operating 5 plants all over North America, US and Mexico. We've got about 400, I'll say roughly 450 team members. We don't normally like to talk about our sales volume, but let's just say that we believe we're probably the second largest heat treater in North America behind Body Coat. And we perform a real wide variety of processes. We've always tried to be, if not on the leading edge, at least a very close follower in most areas. So we do everything from continuous heat treat, quench and temper, to brazing, to vacuum heat treating of tool and die. We also do a lot of work in the aerospace industry and super alloys. We've been doing FNC, for example, for decades, whereas that's sort of a growing segment of the business, but we've been doing it for quite a while. Some things have kind of come and gone over that period of time, right? So shakers and rotaries and things like that, we've replaced over a period of time. So that's kind of what we do.
So you started back in 1981, as I'm reading your CV. So all your life, you've been devoted to heat treat. Is that right? Is that accurate to say?
Yeah, really, my whole professional life has been around Paulo. Took a little detour when we tried to set up a business to operate heat treat plants, captive heat treat shops. That didn't go as well as I had hoped. I found that I could really do better by just trying to concentrate on improving Paulo and growing Paulo.
Right. It's always that like a wish. Yeah, when you run a captive, you lose a lot of flexibility, right? So
well, yeah, in that situation, it's also very important to have the right partner. And
yes.
In that situation, they had bitten off a little more than they could chew, so there were some issues that we weren't going to fix.
Well, so now you've been in the heat treat industry for quite a while, and before we started recording, we were talking about how things have evolved. How communications, technology, controls, processes, furnace technology as well, have been involved. So, and you actually have grown the company with your team members to be what I would believe it will be like the biggest private heat treat company in the US. I believe that's accurate to say. But you know, for yourself, what has been the outstanding changes on the heat treat evolution since you started till now? Of course, we got the internet in the middle of in 2000s. We got a bunch of computer stuff, internet. But what for you, what are like the milestones that you will remember?
Well, I'd say it's sort of a continuous evolution of technology, and a lot of it centers around control. So the development of PLCs, the development of programmable, even dedicated programmable controls on heat treat furnaces, the ability to gather data electronically. I mean, when I started out, it was purely, strip and circular paper charts.
Right.
So all of those kinds of things have continued to help evolve. There were no, we used manual dew pointers to control atmosphere, and we manually controlled all of the gas flows in order to dial it in. And really nobody does it that way anymore. The ability to use systems to plan the process for parts, and to be able to recall that every time, so that you're always doing the same process when the same part comes in. Those are all things that we saw a need for when I was starting out, and we're just at the very beginning of being able to implement. To now where we have tens of thousands of specific heat treat recipes for tied to particular parts for particular customers. We were able to download all of that into furnace controls. That was unheard of. I mean, I couldn't even dream that up when I was starting out.
And I got to interrupt you there, sir. Sorry, but back in, right now, especially when you work with automotive and aerospace, they're all about data. If you have like the backups and everything. How was back then with those guys? Did they had such a level of data collection back in the time? I mean,
I got to say, when I started out, the only people for whom we kept we had a quality manual even was for the for defense work. So we were doing we were in St. Louis. We were doing work for McDonnell Douglas and people like that, who were who ended up being part of Boeing. And we were heat treating structural parts for the Phantom Fighter and things like that. And so there was really no data collected. Somebody might say, well, you need to keep the charts, but nobody ever looked at them.
Right, or analyze them, right?
Yeah, there's no feasible way to do that. Now all that data is in there, and you're building databases, and your biggest risk is that the database crashes and you got to rebuild it,
right.
But which just happened to us yesterday on something. So so now it's cybersecurity all the way down to the furnace controller, right? I mean,
that is something really big, and I was going to touch this subject later on, because right now everybody's talking right now. It's a full podcast about cybersecurity.
We can talk about it later for sure, but I guess my point is that really a lot of it has been driven by technology. So a lot of it is driven by information technology, whether it's the internet, whether it's the ability to gather data, whether it's the ability to program things. Literally, when I started out, when you started on the shop floor, you put a notebook in your hip pocket, and everything that happened, you wrote it down, and that's how you learned. And that's how
it is.
that's how all the guys that worked for me or worked for my father or my grandfather, that's how they all learned. And everything was in that hip pocket notebook. Tempering temperatures for specific tools, all sorts of stuff that they kept records on. And those guys were, I hate to say it, but there were more. I'd say there were more craftsmen in those days than we expect or even want our current heat treaters to be, because we don't want people now to make it up on the fly, and we don't want people to, one of the big pejoratives in the quality world now is tribal knowledge, right? Somebody says tribal knowledge is a bad thing. So, the whole, I don't know how we ever got anything good out of the door when I started out, because everything was based on tribal knowledge. But
it is, and just to make an addition to your comment there, sometimes heat treat, even nowadays, is described by the non-metallurgist as an art, right?
yeah,
Like black magic.
right.
And I believe controls technology now with the machine learning, we have been able to understand a little better the results, because everything is so repeatable. Wouldn't you agree with that?
I do agree with that, but I'll say that you've really got to understand the data, and you've got to understand where it comes from, how it's produced, and what those conditions are. What I often see when people are trying to work just from the data is that they focus on something that's, not as relevant as a lot of other things could be in the process. And so it
We
does.
live on a, I mean, we live on a time, on an era that, you can measure everything, right?
Right.
And you can storage all the data you want. But if you don't have an architecture or a data engineering process, you can have everything. You can have every process variable storage in the hard drive. Like
Right.
you used to have your charts, your paper charts
Right.
in the warehouse. But the important thing right now is what to look at, which data to look at the trends, and how you can actually improve the process or troubleshoot the mistake or even prevent it.
Oh, I totally agree with that. I guess what I'm saying though is that understanding the metallurgy behind it, understanding how furnaces behave, is really important, to marry the two. That's what we call. You were chuckling at me a little bit earlier when I used the term data engineering, which is a tagline we've come up with.
I love that. I love that.
But you've got to understand the data, but you've also got to understand the engineering principles behind what you're doing. And if you don't, then you can easily go down a rabbit hole with the data and get off into something that isn't really going to help you that much. The idea is not to over control something. The idea is to create a set of controls that will produce a repeatable, I'd say good enough part for whatever the function is, so that you aren't trying to create something that's perfect, and is too expensive to produce. So you have to have that reality of what is this really, that we're trying to achieve, and what is the customer's real need, so that you're not creating the kind of waste that comes with over control or overproducing or overdoing it. And so that's where I think people do get into a little bit of trouble. And I think it's not necessarily a fine line, but it is definitely a path you've got to stay on.
The digitization or Industry 4.0,
Mm-hmm.
I believe that has been like the biggest change of the industry, the really
Yeah.
disruptor out of it. Companies that did not embrace technology, did not embrace change, and that they're still using Excel as their way of working process, workout,
Mm-hmm.
are the ones that are being left behind. And the ones that, are measuring the data engineering, the data points they need to collect. And the ones that are actually analyzing the data and take a
Right.
look at trends are the ones that are going to have the biggest advantage.
I
I
agree with
don't
that.
think I don't believe we're there yet, but to a point, I do believe that there will be some machine learning. The challenge that we're having is that we have such a variety of processes and furnaces types, like
Right.
a mesh belt that does carburizing or tempering, and then we have a pit furnace, and then we have like an IQ furnace that does carbonite tritting or a pusher. So the real challenge will be to standardize all the data so we can see it for furnace type, process type, and then part type. So I believe we have become, as heat treaters, really good at recording data, right? But we
Mm-hmm.
are not there yet to analyze data. I don't know if that's a fair statement.
Yeah, I think there's some truth to that. Um, the you know the simply There's a ton of data that you can collect from a heat treat system. There's a lot of data, and the actual reality is that from our standpoint is that we're trying to make sure we're now looking at, you know, massive server farms, and things like that. And even it doesn't make a difference whether it's on premise or in the cloud. It's a lot of data, and we're actually now going through the process of trying to figure out, okay, so how do we pick the right stuff? How do we not uh, uh, waste millions of dollars collecting data that nobody's ever going to need or want? And so we've actually kind of gone full circle, but not, I won't say full circle, but we've actually turned a corner there where we're saying, okay, it isn't really sustainable. It especially is not sustainable for what I think is going to be happening, which is I think that there as things are more distributed, people are going to need heat treaters who are a little more agile and are able to be closer to them, maybe operate a smaller operation that still is highly efficient. And so you have to start thinking about what that means, because not every heat treat location should be this large attempt to reap economies of scale. So I think when we talk about the future, I think that's one of the things that I'm thinking about is how do you do that? We're pretty good at, I mean, you've got a large operation. We've got some very large operations. We're pretty good at fine tuning those. But when you think about a smaller operation, how do you make that economical? And some of these systems are not sustainable on smaller scales.
Oh, they're not, because of the fixed cost, right? If you have a bunch of operations and you want one big server, one big software, you can actually split the cost on all the locations, right? But
Right.
if you have to, licenses, things like that, licenses are pretty expensive.
Yeah.
Now, having said that, digitization is industry 4.0, super big,
Hmm.
disruptor in the industry. Now, everybody's talking about additive manufacturing right
Yeah.
now. The universities in California, and we have had a couple of guests on the podcast talking about additive manufacturing, and that's how it's going to impact heat treat.
Right.
What's your opinion on additive manufacturing? I know that you have also invested as a company on the HIP process, the HIP
Hmm.
process, which is tends to be for that niche in particular. But do you think in let's say in the midterm or long term, there are gonna be no foundries, no forgings, and everything's gonna be additive manufactured?
I,
I find it hard to believe, right?
yeah,
But we
yeah. I
live in a
mean,
crazy world.
you know, I kind of doubt it. I think I'm pretty sure, based on everything that I've seen, that there are, it's kind of like any other new process, right? There's always kind of room for, for a variety of technologies, and it's going to displace some things, but it's not going to displace everything.
Mm-hmm.
And if it does, it won't. It'll be the problem of my kids, and young guys like you won't be my problem. But
That's
the
what I'm asking you because it might be my problem. So that's
yeah. So, but I'd say so. The approach we're taking to that is we invested uh, in our first HIP unit. We invested in a unit that has very rapid cooling capability, and we decided that what we wanted to do was go after the additive market, where we could help develop from scratch, essentially, process requirements and standards. So we're working with a number of the companies that build additive manufacturing, AM printers, 3D printers. We're working with some of their customers to develop the optimum process. So whether it's the HIP process or whether it's the heat treat process, or really the end goal is to try to combine the two. Um, that and one of the things that should be the promise of additive manufacturing, in addition to being able to make very complex components in single pieces, as opposed to, multiple weldments or brazements or that type of thing, is so make them in single pieces and make them fast. So speed is really the thing in my opinion. So what we wanted to do is we wanted to start down the road of combining HIP and heat treat for those people, turning days of turnaround into hours of turnaround, and that type of thing. And so that's sort of our vision of it. And I think that I think we'll get there. But you got to remember that, just like we were talking about earlier. So over my career, specifications and so forth have become more and more complex.
Right.
All right. So, and that's been done for a reason, right? That's been done to get, consistent quality, for safety, and in some ways to reduce costs by being able to not have parts over-engineered and things like that. So what, but all of those specifications and requirements are out there, and they're probably, and so let's just say the FAA is not going to abandon their requirements for process control in favor of something that's not proven. And so now we're in the process of running lots of trials for people, doing research, trying to, we've been publishing, or our metallurgy teams are publishing co-authored papers in this area. And so we're really trying to add to the scientific knowledge at this point. And it's a long slog, and it's not for the faint of heart, because as probably many of our viewers of this know, hip equipment is not inexpensive, and hip equipment that will do what we're talking about is not inexpensive. And so it's going to take a while, but in the end, I think that it's required in order to facilitate the growth of the additive manufacturing industry, which is, the beauty of which is that changes in the end should be easier to make in design, sort of customization and all that type of stuff should be enhanced. All the things that, when we talk about lean and all that, the things that we really were trying to accomplish. And
I wanted to make a comparison with HIP and additive manufacturing.
Yeah.
When the single chamber, or when we had LPC technology,
right.
Everybody say, well, there's not going to be a niche or a market now for IQ furnaces, right? Everybody thought
right.
that we're doomed, we're dead. We have a better process, a cleaner process. But, then everything settled down and say, well, the LPC technology, tends to land here really well, but
right.
it's very expensive to treat this stuff on an LPC. We should use standard technology like IQ. Then there are salts over there, and now these new processes like nitriding or FNC and HIP are emerging, are gaining a lot of strength. But my prediction will be that everything's going to land there. Of course, there are going to be some big winners, but I don't believe that HIP will be the answer to the 100% of the market, right?
Oh, I don't think AM or HIP will be. I think it's just another tool, and there are advantages, and we're, our intent is to capitalize on those advantages where they exist. There's no way that it's that I think it can replace everything. Just as you said, I mean, there are, if you look at LPC, it's really not a good way of producing parts of certain types, despite the cost. I mean, the results aren't as good for certain things. So, and I'm sure that'll be the same with what we're proposing. I'm merely sharing our vision of what we think the advantages will be and where we're going with it.
And we haven't talked much, but there's also like a big boom with aluminum as well. Everybody wants to make parts lighter, right? And also, if we talk about additive manufacturing, which heat treaters are a little scared of, there's also the electric vehicle, right? Which also automotive takes a lot of heat treat, right? But they're going to say, gears are going to go out. We're going to lose so much capacity. But processes like FNC, are on the rotor brakes, seat belts, it's out-tempering. So there's still going to be a bunch of heat treat for automotive that I tend to believe that it will be hard to do on additive manufacturing.
Yeah, if you want to switch the topic a little bit to electrification, I think that's right. I mean, yeah, it'll just be different. And we do a lot of work in the seating world for automobiles. So if you think about the, you can't even buy a car today, I don't think, without six-way power seats. And every one of those adjustments requires some sort of motor and a gear and they have to be, they're tiny, and yet they have to be strong enough to withstand crashes and things like that. So where the heat treaters come in, right? We may, we're able to work with those manufacturers to give those parts the mechanical properties they need for the designs that they're coming up with. And I think that's all. It's going to change, but it's it probably is going to take a little bit longer than some people think, but nonetheless, it will change. But it won't be the end of the world. I mean, resources just get moved around, right? I know a guy whose business started out in the 19th century selling axle grease for the wagons for the settlers going across the United States, right? That was his business. Now, he still sells a lot of lubricants, but he doesn't sell any lubricants for wagon axles. All right. So it's just a matter of that we're going to find new applications, we're going to find new technology, or find new things that people want to do. And I mean, who would have thought really seriously 30 years ago that now we'd be we'd actually be seeing people space tourism, right? Just in the last. So all of those rockets and rocket engines and all that material, all those things have to be built some way, and they're all being built in ways that are substantially different than the ways we built spacecraft for the space program in the 60s. And so it evolves, and it becomes something different, and but it all still needs it's still got its fair share of heat treat content in it.
It is, and I believe this is a great subject because as the automotive market is evolving, we talked about electric car and additive manufacturing. Now we're seeing a new niche, and that Richard Branson just got, space tourism, and I believe we're going to see that in the next 20 years, 30 years at the speed the curve is going, right? So do you envision like a disruptive new type of metallurgy, not process, but that will need different process, because we're talking about titanium, some special types of stuff to travel out of space that we haven't seen yet? I do believe you're in the right track, doing R&D with suppliers and additive manufacturing universities, and those specifications for space travel are going to have a very complex and very narrow specification. So what's your opinion on that? As other markets are maturing, automotive, right? Aerospace just gave us like a big, like, this is going to happen, this is going to be big.
Yeah, so let's go back to basics.
Okay.
There's only so many metals in the periodic table. And so so that's the universe of metals. So if you're really thinking about metallurgy and metal, heat treating processes on metals, then I think we'll find that things are utilized more or less over a period of time than they were before. Maybe titanium is used, or titanium and titanium alloys are used more, aluminum alloys, and maybe ferrous alloys are used less. I don't know, but all of those things ultimately require some kind of, are going to require some type thermal processing, really. And uh, and so I don't think it's going to go away. I just think I just think it's likely to be very different. I mean, um, but the uh, things like if space travel becomes a mass thing, or even let's call it subspace, these supersonic type things, sort of which are not really the rebirth of the SST, but are more maybe new things. If those things actually take off, if we can figure out how to do that economically, that it makes sense, then you know you you there's a lot more use, for example, in some aircraft now of carbon type materials, carbon-based materials, as opposed to metallic materials. Carbon fiber and that type of stuff. So, there probably are going to be shifts, but I don't think it's, I think we're going to have time to adapt. I think we're going to have time to change business models. I think we're going to will evolve. I don't know, what was your company doing at the beginning that you're not doing at all now, right? Probably a lot of things.
And I do believe as well that the added value will be big. I mean, the more added value your company can bring to the table, not only heat treat, will also be very substantial, because it's very right now heat treaters are competing most of the times with price, right? And if you talk to a customer, we had a previous podcast, and the guest was saying that some of this space program heat treaters get designated to the cheapest one, right? Of course, they have to meet the specification, right? But I do believe the more the specifications, the complexity of it gets bigger, the flexibility has to be, single parts, nice price, really quick, different types of volumes, right?
Yeah, exactly.
The one that has more flexibility, right? More speed to response, and will be the winners.
Yeah, and that's all. That's the way it's always been. It's about bringing your knowledge to the table, solving problems for customers, helping customers recognize that things could be done better. Some of the biggest projects we've ever done were done because we were walking through a customer's plant, talking to people about problems they were having or challenges that they had. And then light bulbs start to go off. You say, you know what, this could be done a whole different way. Can't we talk about that? And and that it's amazing what, when you can really collaborate and bring value to the customer where they trust you, what you can do.
And it's been amazing talking about all types of the evolution, the process, the trends that you're seeing, different processes. But I gotta ask you this, because I'm pretty sure that you have been in many captive shops, on many customer sites. You have a bunch of locations. But what are the first things that you look at when you enter a heat treat shop, no matter if it's captive, no matter if it's commercial? What are like the key things? If it's cleanliness, if the parts are stacked, I got a bunch of answers from this one, but I'm really thrilled. What are like the first three things you look at when you go into a shop?
It's not just looking either. I'll just say that. So it's, at least in our shops, I would say that sometimes our managers you know, might be a little bit leery of me walking in the door. The main reason is that after you've been doing this for a long time, um, it's as if whatever the sounds, the sights, the smells, um, it's almost like you're like a magnet is drawing me to whatever the problem is.
Mhm.
You know, a lot of times the problems create disorganization because, well, let's just say a problem is that we can't get consistent quality out of something. So then there's stuff stacked around that has to be reworked, or, you know, or things like that. Or maybe there's a problem with, um, uh, you know, a lot of what we do is handle material, right? Is it, you know, the heat treating is important, but the
Mhm.
material handling is also very important. So things like packaging and how we handle customers' parts and all those kinds of things. And so you just begin to see and hear things that just sort of draw you to that. So I would say one of the things you mentioned is organization. I think if a shop is organized, um, and they can maintain an organized atmosphere, then that generally tells you that it's at least running the way they want it to run. Okay. Um, but you know, you hear a burner pop, or you hear you know, something you know, is moving along and it's making a big squeal, and or, you know, any of those types of
Right.
things. So it could be what you see, it could be what you hear. um you know, you like I said, we do a lot of nitriding and FNC and carbonitrating. So
Right.
ammonia is often a
What you
giveaway.
smell? Yeah, it is.
Yeah, exactly.
It's
Whether
another
your
shop.
whether your sinuses are being cleared out, but the so you know, it's that type of thing. But when I walk through, when I first get there, I usually am looking at, is it organized? Does it
Mhm.
seem like the equipment is in good repair?
Right. Safety.
Yeah, well, not only safety, but it goes to quality too. You know, I mean, our our furnace doors, do they appear to be tight? Are flame curtains uniform? Are uh, pilot lights lit? Are you know, just all those types of things, right? Are there, you know, is you know, another one is that we move a lot of heavy stuff around, right? So we have
Mhm.
forklifts, all right. So um, you know, do the forklifts have a lot of scuff marks on
And another question I always like to ask to the guys that run several shops at the time. For you, what are the top KPIs you need to look at every plant, no matter how different they are?
Oh, okay.
What
So
how will you standardize those to measure the performance of each?
ours are labor productivity,
Hmm.
um, furnace productivity, uh, you know, quality measures. So whether it's cost per quality, or even more simply, percentage rejected, either internal
Hmm.
or external, either or internally and externally.
Right.
Um, so, and we actually have a measure that's, uh, the percentage of orders that have no problems for the customer, meaning
Hmm.
they're, the quality's right, the parts are packaged right, they get delivered on time, all that kind of stuff. And, we strive for 99 something. And,
Good.
and then you've got safety. So we keep track of the number of safety incidents we have. We keep track of our, lost time days. We keep track of all that. And um, we also look at orders. So we keep very close track of our meeting our delivery dates.
Hmm.
Uh, so we've got sort of a whole kind of balanced scorecard there, that's quality, delivery, efficiency, safety, and that's really what we do. We also track all customer complaints, and actually really it's broader than that. All customer feedback. So whether it's good or bad, we try to keep track of all of that through our CRM, and and we look at that um, at most of those on a weekly basis for every plant.
Thank you for sharing that. That's very valuable coming from you, and I believe the audience is going to find that very valuable. Thanks for sharing that and being so open with us. Now, just to finish up our podcast, time's up. It's been fantastic talking to you about the trends, the problems you're seeing for the fifth generation of Polo, not the fourth, the fifth. So those are the problems you're envisioning. Like my grandkids are gonna have to deal with this stuff. So that's fantastic. But I always like to close the shows with people with your level of experience that you've been 44 years around, right? On the heater industry around it. So what advice would you like to give to the new generation of heat treaters? Let's imagine that you have a time machine and you could travel in time and meet yourself when you were like 28. Well, 25 years old, let's say that you're starting on the heat treat shop on the floor. You were writing your tempering temperatures on your notepad. You didn't have PLC. You had relay logic. What advice? It doesn't have to be technical, right? What advice would you like to have been given if you could travel back in time?
I think the first thing you have to know in this business is you've got to be persistent. You're going to make mistakes. Your first attempt at something is not always going to be successful. And you've got to be persistent. You've got to be able to pick yourself up and try it again. And the second thing you have to do is you've got to learn from those mistakes. You've got to learn the lessons. One of my favorite is, hey, we just paid the tuition. Let's make sure we learn the lesson. And if you do that, I think that you can build a career that has a foundation of real knowledge. And then the other piece of it, I would say, is you've really got to focus on your customers. You've got to understand what your customers need. You've got to keep building toward that. You've got to work with them. You've got to develop their trust so that they will work with you, and that they won't try to lead things down the wrong path. It's hard to say that the customer's ever wrong, but oftentimes the customer doesn't have the benefit of our knowledge of the process, and it's a tragedy to leave to leave them in the dark on that. You've got to lead them along, and you've got to share information so that you can together develop the right answers to their problems.
That's fantastic. Oh, I got one last question now that I have you here, and you brought the subject of the customers. With this complex specification, with now business being so much intensive and aggressive, that being particularly the way the automotives are designed to be. What's your opinion on how to push back a customer, and to which point? Because especially when we have automotive customers, they're very pushy, always more, cheaper, faster, right? What's your take or your opinion? When do you have to push back, or other people take to approach like, I'm not pushing back if the price is right?
Oh, well,
This is a tough one. Sorry to put you on the spot.
No, that's a very
I struggle every day with that, and I would love to have that.
It's a very situational thing, but I think what you have to do is you've got to know, you've got to have in your mind what your value is. You've got to have in your mind what a customer really needs what you're delivering for them, sometimes you've got to say to yourself, you could say to yourself, well, they just don't value what I have to offer. But sometimes you have to say to yourself, I wonder if I'm putting more into this than is necessary to really satisfy them, and that we could give it to them for, say it's a price thing, could give it to them for less. But you got to think about how do you streamline what you're doing if you're going to do that. And so you've got to look at it from both directions. But at some point you just have to say, okay, so I can't continue to invest in this. It doesn't make any sense. And then that's the point at which you have to say, we really need to, we're really going to have to draw the line here, and this is what we're going to do. But you get yourself into situation. You can easily, I've seen it so many times. You get yourself into a situation where that's a very difficult call, because you already bought the furnace. It's paid for. Okay, you got to do something. You got to do something with it. Do you want it empty or do you want it full?
Right.
And
I believe that's like every heat treater struggle, right? Like,
yeah, well,
right?
you can overinvest. I've been guilty of that before. I love new furnaces. I love to think that we can take this thing to the moon. I love to think that. But at some point you go, I wonder if this is really as good as I think it's going to be. And
right.
So that's just the nature of it. You've got to invest, but you've got to be careful what you do.
Thank you for sharing your experience and thank you for your wisdom. I do appreciate you taking the time to speak at the podcast. Time's out, Ben. Just would like to thank you again. You are really a power player, an example on the heat treat industry. You're investing on R&D, on new processes, family business. Your third generation, right? And the fourth generation is helping you running the company. So I respect that a lot. And I just would like to congratulate you for the work you're doing. The strength you're putting on the heat treat industry and being so open to share what you just did with us on the podcast to the audience. Thank you so much, Ben. And
well, I appreciate the opportunity, Carlos. I'll let everybody know if they want to know more about Paulo. Just a little bit of a plug. We're going to be rolling out a new website here in the next 8 weeks. Paulo.com.
We'll leave the link over here.
Yeah, and I appreciate anybody who's taken the time to listen to all of this. I probably went on a little bit too long on some things, but thank you very much, audience.
Not a problem. And if you get any business from this podcast, remember my cut is 3%. Thank you so much. And I just would like to remind everybody on the Heat Treat podcast that we're posting weekly podcasts with power players like Ben Rassieur, president of Apollo Products. And we're on YouTube, Spotify, LinkedIn, right? And we'll see you next week with another power player of the industry.